We'll keep moving. We got our next company here, Bounce Imaging, and the CEO, Francisco Aguilar, who will take the lead here.
Okay, great. Well, thanks very much for your time. We really appreciate it. I think, as you've probably heard with a lot of the companies here, we are really motivated to start talking to partners because we have a product in the field with special operations teams and Army units that are telling us that this is something that's saving lives and making a difference for them. But we don't, as a small company, we don't know how to scale that to a program of record to hit the level of impact that we think we can. So it's great to be talking to partners that know how to do that and have done it many times. So if you can go to the first slide, please. This is the problem we solve, and it should be one that's pretty easy to empathize with, right? The idea of being ordered to go down into a Kavez system like this without knowing what lies ahead, it's a truly terrifying thing to ask someone to do. And on the next slide, you might think, well, aren't there all sorts of robots and drones and fancy tools that should solve this problem? And the reality is that there are, but realistically, they're very expensive. They're hard to use. They're hard to carry. So they're very rarely available immediately when you're approaching something like this and have to act quickly. And they always have a limited field of use. You're always trying to look at the world as if through a straw. So on the next slide, what we do is we make omnidirectional cameras. In this case, a throwable omnidirectional camera. Something you can toss into an environment, put on a pole, put on a rope, and get an instant 360-degree view that allows many people to be looking in many directions at the same time to get complete situational awareness before having to enter any kind of dangerous space. And on the next slide, we'll see a video.
The dangers that we face are we're going into kind of the unknown.
You've got somebody in a room, you don't know who it is, you don't know numbers, you don't know if they're armed, you don't know if there are innocents in that room.
When you enter that structure, you have to read and react, figure out where the suspect could be hiding, and all that happens within seconds.
I've got 42 years in law enforcement. I've learned that the real safety component for a police officer is knowing what they're going to get into before they get there.
Police, open up!
I mean, how do you do that? Well, this thing gives you that opportunity.
And Guy, you can probably skip ahead to the next slide, please. So this is what a normal canine camera looks like when you put a camera on a dog. It's just, this is actually their marketing video. It's unstable, it's messy, it's really hard to know what's going on. When you put a 360 stabilized camera on a dog, you get this kind of video instead. So you'll notice, even though the dog's spinning left and right, going back and forth, we're still focused on what we care about, no matter what the motion of the camera is. And then you can stop or go back in time, and you can look in all directions, cover all angles. Tons of different ways you can visualize it, wide angle, fisheye. So you can get total situational awareness around, in this case, a dog. Cool. We can probably go to the next slide. And so the core technology behind this is a combination of hardware and software. Software that's much more efficient image processing and stitching, and that's resistant to any kind of noise. And hardware that does a very precise synchronization and allows you to do things like, on the next slide, throw a camera off a bridge, and on the upper right, you see what a normal camera would see, and on the main screen, you see what our stabilization allows. Similarly, on the next slide, we can put this thing on a rope down in a tunnel. This is very relevant to sub-T operations, for example. You can see how the camera can spin on a rope and yet still be focused on what you care about. So next slide, please. And that technology we're applying in all sorts of different ways. The ball is the first form factor. You already saw how you can apply that to a dog. We've put that on robots, we've put it on drones. We're integrating that with ATAC. As part of this X-Tech Search project, we're moving out of the visual spectrum and into the thermal range of visualizations. And then most recently, we've been integrating to IVUS, which you all probably know the Army is spending a lot of money on. So if you can go to the next slide. Womp womp. All right, we'll send that along next. We're deployed with hundreds of police departments and military units. Next slide, please. And the goal of this is really to make a job that's already very difficult a little bit safer by giving people situational awareness in the most challenging environments. Thanks very much for your time.
Awesome. Great. Thanks, Francisco. I think one question you might be able to shed some light on is kind of what was the nexus for all of this? You know, so there's obviously some really interesting technology breakthroughs embedded within the ball, right, and within your core IP. Where did that all start?
Well, it all came from user needs. So we started looking at where we were actually first looking at FEMA teams and how they were looking inside collapsed structures. But as soon as we started doing the technology, we were immediately approached by tactical teams that said they had very similar problems looking inside dangerous spaces. So all the technology was driven by the end user need rather than sort of finding a technology and trying to shove it into a use case.
Awesome. Another one, I'm wondering, you know, so, you know, these teams, what do they do today, right? Especially in the armed services, the special operators, the people who are going into caves and need some, like, how do they get that information today before they enter those environments?
Yeah, so it's a very good question because, and something we talk about with the teams that we work with currently, often they will be sending either themselves or partner nation security forces or one of their canines through the door instead of without really much situational awareness. And so one of the things that they've told us is that this actually builds a lot of confidence for partner forces when they can toss this, they come to outside a compound, toss this thing in the air, catch it, and then go back in time and look into the compound from above. They can build the confidence of somebody going through that door that there's not someone about to shoot them on the other side. And so it's been really useful for very quick overhead surveillance, you know, on the other side of a wall, where previously they just had to go through the door. Or they had to send in a dog, or they had to send in a partner force. So there's limited things. Sometimes you could use a drone or a robot, but they're rarely available immediately.
Got it. Another question came in privately on the we'll call it, like, maybe if there is one, an upper limit, kind of the image stitching technology. You know, like, think in totally different situations of surveillance, or, you know, a lot of the big strategic partners already have their own imaging systems.
Yep.
How do you envision your tech, your software, whatever it is, dovetailing into to make their systems even better?
Yeah, the neat trick that we have is that we are much more processor efficient than traditional methods of stitching. We're not sensitive to noise. So, for example, when you apply traditional stitching to something like thermal, it's very noisy. Either you have to do a ton of processing to get rid of that noise, or it just breaks. Because we're not using a feature matching method, we can work in a whole range of environments with 3 of our cameras knocked out that traditional processes wouldn't work with a lot less battery power and a lot more effectively. And then the stabilization that goes with it is pretty unique relative to other systems that are out there.
Got it. Cool. And then last question, what are some of the interesting, like, you know, people who are in the line of, this is a great use case, as you found, being customer centric. Any other interesting ones, maybe in the private market, where you know, just this 360 imaging is really helpful even in non-emergency situations?
Yeah, so some of the more random ones that we've been asked for sporting events to use it for, we've got a couple of potential projects to use them for, like, in a baseball or in a basketball. So you could throw it into a hoop or something and give the ball's eye view of what's going on. We've also recently been talking to some BBC documentary folks about putting this on tigers and snow leopards and things that are pretty hard to. And then more sort of like less fun, but pretty useful, is industrial safety applications. So we're talking to a lot of oil companies that have, like, rigs where they have to do a very quick inspection before they escalate to bring in a more advanced asset. And they want to have a quick way to communicate over 4G or over a network what's going on for somebody 1,000 miles away on a VR headset to see what's going on before they decide to bring in the heavier equipment.
Got it. Perfect. Sweet. Yeah, I like the documentary or basketball, soccer. That'd be sweet from the commercial standpoint. But Francisco, thanks for the pitch. Great information and really, really cool stuff. Great story about how you've been super customer centric here. So thanks for sharing.
And thank you very much for the opportunity. Appreciate it.